Good evening, statisticians. It is time for another exciting, thrilling video involving residual plots. Now, the previous 3 videos, we have talked about making a scatter plot and commenting on the direction, form, and strength of our scatter plot between our 2 quantitative variables. Then we talked about, in terms of strength, we can actually tie a number to that strength. And the number was called correlation, the R value in there. And R can be any number between -1 up to +1. If you had a negative association, it was going to be anywhere between -1 and 0. And if you had a positive association, it would be anywhere between 0 and including +1. And if you had no association, if your scatter plot basically looked like a scattered bunch of points that made a circle, then there was 0 correlation, no correlation. So then yesterday we talked about the regression line, that line that fit kind of in the average of all of those points. Okay, so now we're going to continue on. At the very end of yesterday's video, we talked about these things called residuals, which was how much air we had between what we actually had and what we predicted that we would get using our regression line. So again, here was our formula for a residual. And again, by residual, all I meant was how much air that we had between our observed y, or yesterday we said the actual y value, minus the predicted y value. And that predicted y value came from the least square regression line. Okay, that's when you had y hat equals, I'll just make up something like 13 plus 0.5x. And that's when you plugged in an actual number into x and you figured out what that number was going to be, and that represented your predicted y value, which may differ from the actual y value. And the difference between those two was our error or our residual. So we're going to look at an example. It says, does the age at which a child begins to talk predict a later score on a test of mental ability? A study of the development of young children recorded the age and months at which each of the 21 children spoke their first word and Gazelle adaptive score, the result of an aptitude test taken much later. The data appear below. So again, we have child 1 through 21, and we're not going to use these numbers in any kind of list. It's just to keep our data straightened out 1 through 21. And then here are these ages, which represent the month after birth at which they first spoke their first word. So this first child said their first word at 15 months. This second child said their first word at 26 months. And so forth and so on down the line. And then you kind of notice this one, this 42-month-old kid was, what, 3.5 years old before he said his first word. And then this second column here, you know, if we exclude the child column, this column of score is the score on this Gazelle adaptive test, which they took later in life. It wasn't right after they said their first word. Years down the road, they took this test. And they wanted to see, when they said their first word, does that have any kind of predictive success of being able to tell what their score on this test would be later in life. Okay? It's kind of like when you're a kid and you would go to the doctor, and at a certain age the doctor would say, well, based on your height at this age, you know, I'm going to predict that you're going to be this tall when you're done growing. Okay? I know my doctor would say, like, well, when you get to be older, you're going to be, you know, 6 foot, whatever. Sometimes the doctor's right, sometimes the doctor's wrong, but the doctor is using really a regression line that's based on thousands upon thousands of children's height at a certain age and their height basically when they're done growing. And all he does is he puts your age or your current height into this regression line, and it's able to give him a predicted height for how tall you will be when you're done growing. It's the same idea there. Alright, so the first thing you need to do is take out your calculator, and you're going to put all those ages into list 1 and the scores into list 2. So I'm going to go back, and if you need to pause the video at this point to get all this data into your calculator, again, all the ages go into list 1, so you'll go all the way down, and then you'll continue and keep going down here, put all that into list 1, and then in list 2 you're going to put their scores and make sure they match up side by side here, and you'll go all the way down and then continue down until you get to that 100. So if you need to pause the video, put all your data in, and then press play, and we'll go and do the math, the statistics. Alright, hopefully you got your data into list 1 and list 2. First thing we're going to do is we're going to make a scatter plot of our data. So remember with your scatter plot, let me jump ahead here real quick. With your scatter plot, on your calculator you needed to go press the second and y equals to get to stat plot. And then typically you're going to have plot 1, and you're going to press enter to go into it. You're going to want to make sure it's selected on, and then for the type, remember you're going to select that first one that looks like a scatter plot. And then for your X list and your Y list, you want to make sure you have L1 and L2 selected. And then when you hit graph, chances are you're not going to see all your data or maybe none of it. And then that's when you have to press zoom and then select 9. You can press 9 at that point, or you can scroll down and do 9 for zoom stat. And then you should have, let's pop back to here, you should have this scatter plot. Okay. Now the one thing that's included on mine is I went ahead and kind of done this next step here for number 3, but you should see definitely these points. And notice some of the points are filled in. Some of these squares are open circled, or open squared, I guess you would say, and some of them are darkened. Okay, and you might think, why are some points different than others? Well, did we have any double data points back here? We probably did, or they're really, really close to each other, that really those points are probably just stacked, and some of the edges of one square is into the edge of, or into the center of another square, and it makes it look like it's filled in on your calculator. I don't see, oh yep, there's a 10-100, there's a 10-100, so there is a double data point in there. It looked like there may be some others. I can't really see off the top of my head here, but some that are probably just really close and they're just running into each other. So we definitely know there are some double data points in there. Alright, number 3, we're going to calculate the regression line. And remember, to do that, you had to go to Stat, over to Calc, down to number 8, until you get to this linreg a plus bx. And then you had to type in L1, which was second 1, find the comma button, L2, which was second 2 as the shortcut, and go ahead and do this comma y1. And to get to the y1 again, you press the vars button, the variables button, and then you're going to go over to the y variables. I think you just scroll over to the right, and then it should already be selected on function, so press enter at that point, and you're just going to select the first one, which is y1. So that in the end, you have this command right here, and when you press enter, this is what you should have. And again, if you don't see your r and r squared, it's because you didn't watch the second video to figure out how to calibrate your calculator so that it would give you the r and r squared. Again, you would just need to go to your catalog and find diagnostic on, press enter again until it says done, and then go back and redo your linreg command And you should have your r and r squared value there. Okay, I don't know what's happening there. Okay. And again, you only have to do this one time unless you completely reset your calculator's memory. Then you would have to go back and do it. Alright, so for number 3 here, our regression line, what's going on? Here we go. Something funny's going on. What's going on? I think I know what's going on. Okay. Alright, our regression line. Remember, this is our predictor line. Predictor line. This is the line we're going to use to make predictions with. So this is our y hat, not just y equals. I know this just says y, but it really should say y equals. Then the a value. And again, I'm going to go 4 sig figs here. So 109.9, that would be. Now notice my slope, I would usually say plus b, but my b is negative. So I'm just going to say minus 1.127 x. And the x's are your actual x values. And in this case, our x value, our explanatory variable, was the age at which the kids first said their first word. All right. And notice our r value down here is negative 0.64. I'll just do 2 sig figs there. And that kind of makes sense why it's negative, because our points are going down. You would think the older that they are, the not as high they're going to get on this test much later in life. Because if it takes them so long to finally talk, there's probably going to be something wrong with their mental abilities, their mental cognition, that they're not going to score very well later. The younger they are, then chances are, it seems like, if they're in this particular range, this particular age group, then here's where you see that cluster where they're scoring anywhere from here to here. Okay. Now, for number 4, it says calculate the residual for the first child. Now let me clear some stuff up here. Let's see, let's take this, shrink it back up. Now the first kid, I'm going to have to go back here and take a look. The first kid was 15, and here's what I can do. Where did that come from? Alright. I'm going to take a little picture here. So I don't have to keep scrolling back and forth. There's my data I need. Okay. So the residual for the first child. Remember, this was our x, this was our explanatory, and these were the actual scores that they got later in life. Okay. Now we're going to use our predictor line, our regression line, to take the ages of these kids and predict what score they would get. Is it always going to match up with what actually happened? No, it's not. Okay. So the residual of the first. Okay, where was I here? Just got a phone call. Residual for the first child. We're going to take our predictor line and we're going to plug in the actual age for that first kid, our x, into that x right there. Okay? So, we're going to have y hat equals 109.9 minus 1.127 times 15. So now let's whip out the abacus. And we've got, let's see, 1.127 times a 15-month-old, 16.905. So that's what I'm really going to be subtracting away from my 109.9. Really, I'm just going to do this. And then just make my answer that's going to be negative positive. So I'm going to get a predicted score of 92.995. Now what did that 15-year-old actually score? A 95. So my prediction was less than what actually happened. Okay? So my prediction was under what actually happened. I under-predicted. Now, how much was my prediction off by? Not much. And here's where the residual comes into play. So let me take this, bump this up. So now the residual, the formula for that was the actual minus the predicted. What actually happened was the kid scored a 95. What we predicted he would score was a 92.995, which leaves us with 2.005. And again, that's how much air we were off by. Okay? Now notice this is a positive 2. There will be cases where we will have a negative residual, where we predicted too much. We overestimated in our prediction. Okay? So let's do this again for the second child. And once we get to the third child, we'll skip that. But let's try it again one more time for another kid. Alright, so again, we're going to use our regression line, the same line because it's for the same data. But now we're going to predict what the score is going to be for this 26-year-old. So we're going to plug 26 in for X. And so let's figure out 1.127, oh, dang it, my point in, 0.127 times 26. So 29.302. Subtract 109.9. Again, I'm just going to write the positive version of this. 80.598. Okay. So again, this is the predicted score for our 26-month-old kid. What score did he really get? Oh, he got a 71. So again, when we look at residual, just going to take that away. What he actually scored was a 71, minus what we thought he was going to score was an 80.598, which means the amount of air that we were off by is, this is bad, I'm going to have to use a calculator. I hate going backwards. 71 minus 80.598, negative 9.598. Now, again, it's okay to have negative residuals, negative air. That just means we predicted higher than what really happened. We overestimated when you have a negative residual. It's almost kind of the backwards way of what you think is going to happen. You would think that if you had a positive residual, that you overestimated. But it's really the other way around. Negative residuals, you overestimated. Positive residuals, you underestimated. Now, if you want to do the residual for the third kid, knock yourself out. What I'm going to show you is a shortcut so that you can do this in your calculator for all of the kids at the same time.